And you
I'm gonna
guys.
go ahead. I'll go ahead and post it here in the purple pill and put it up there in the jumbo, and you can just look at it and you can tell me how that works on a ball that you say we don't have any proof of.
And if I would send you a photo, you would say a picture is not a proof.
Well, you see, I didn't take this photo. As I said before, this is a legit world record in the Guinness Book of World Records photo. So you can get this photo, you can get this information, uh, yourself. So uh, there's that. And let's see. I just put it up there in the jumbotron for you. You can look at it in all its flat Earth glory. It's the ultimate globe buster.
It's yeah. There's a 10-15 seconds delay. So
Oh yeah, it'll take a couple seconds to
yeah.
get up there.
But Sol, I want to ask you another question. Like let's talk about water if you don't mind for a bit, right?
Yeah.
So you know that water stays at rest only in a container. Would you agree?
Only in a container. Yeah.
Yeah, like water at rest stays at rest, but only in a container. Would you agree?
Yes.
Okay. So when you look at a pond, you look at a canal, you look at a river, you know that that's in a container, which is that the ground is at a higher elevation containing that large quantity of water, right? So you can have smaller quantities of water that look like a hemisphere or a sphere, those drops that you see on your sink. But once there's a large volume of water, water spreads out and it seeks its level. Would you agree?
Uh, yes, I want to uh, say no to your first assumption. Or um,
Okay, well, like regardless, like large quantities of water,
yeah.
eventually they're gonna try to find its level. Would you agree? Like they're gonna try to find its balance.
Yes. Yes.
So if that's our observations for all large bodies of water, right? And you're an atheist, so like you don't believe in God, you don't believe in the Bible or any type of, magic or spiritual religion at all, right? That's what you
Mm,
said?
yeah.
So yeah, you don't believe in any of that because you can't see it, right?
Yeah.
Okay, so if we've never seen this strange, mysterious force of gravity, right, that apparently is not made out of any particles, right, because it can't, because supposedly it's objects of mass attracting each other. And if it's made out of particles, that doesn't happen. So, how does this faith of this mysterious force called gravity curving the water into a sphere, right, sticking it on the side of a larger ball, how does that make sense?
If mass attracts mass,
In mass does not attract mass.
uh, yeah, but that's what our the
Uh,
common science says.
yeah,
No, no, sorry,
common science.
curvature. Yeah, yeah, yeah. Mass, a large mass bends time and space, or space time, or
No, it doesn't do that either.
yeah, it does.
Can you prove that?
Everything we see when we
Can you
look
prove
at the universe or look out to space.
That's a no. Thank you.
No, but that's what we see.
No, you see the same stars that you see every single day, man. That's all you see when you look at this. That's the only thing you've ever seen forever is the same stars up in the sky, man. Stop telling me about bendy space time. Seriously.
Yeah, but if
Yeah, but
okay,
yeah,
yeah,
but
okay, yeah, hear me out. Um, Moon is fairly small. But if
how fairly small is it?
like the sixth of us of the planet of our planet. Uh, well, let's say if there's a star.
What if I told you that the Earth was bigger than the moon? Would that freak you out?
No, Earth is bigger than the moon. The
What
moon,
if I told you that Earth was bigger than the sun and the moon? Would that freak you out?
yes.
Does it look like the sun and the moon are bigger than us when you look up at the sun and the moon?
No, because they're very far away.
Are you sure about that? How far away is the sun?
8 light minutes, whatever that.
Eight.
Whatever that's in your.
Are you saying that because that's how long it takes a photon to go from the sun to the Earth is 8 minutes?
Yes.
Is that what you're going? Yeah. Do you know what the actual distance is that it takes that 8 minutes? It's one astronomical unit.
Yeah.
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 Do you know how much an astronomical unit is?
Yeah. The medium distance from.
No, it's a specific number on this one, man. You went from an 8 light year or 8 light minutes to an astronomical unit. Now I want you to actually tell me what the astronomical unit is. It's the distance between the Earth and the Sun. You can say, I don't know. But an answer will be needed. Did we lose you?
No, he's got to Google the answer real quick. Brian, just give him a sec.
Give him a second. All right.
No, I mean, I just asked him a question, right? Like, if he claims to be an atheist, because, I can't see God. Well, you can't see gravity either. You could just see maybe the effects. You can argue that, but you can't see gravity itself.
Can't see curvature either.
Yeah.
Brian, that's the one question that a Glober cannot answer, and they always deflect by saying refraction or refraction, right? Everything else is mathematical or impressing with brilliance or bullshit, but they can never define the curvature. Never.
Man, did we just lose Bill? What happened to Bill?
I think he's doing a martini shaken, not stirred.
Man, 2025 technology, man. It's a good thing we didn't have this crappy stuff in 1969 when we went to the moon and made phone calls and played golf and such. Right? Am I right? Am I right?
Yeah.
Oh, sorry, guys. Net switch or something.
So I can't remember my question. Does anybody remember my question?
Yes. How far is the sun from the Earth?
Oh, there it is. No, I wanted you to tell me what an astronomical unit was.
It's a bit short of 150 million kilometers. Whatever that is in miles.
Do you know how much that is in miles?
160 is 160 kilometers is 1 mile. Wrong, 100 miles. So that's 150 million.
Is that going to equate to 93 million miles?
Yes.
Okay.
Yeah, short of 100 million miles.
Because you said that really fast, like you knew it was 93 million miles. Like you just didn't want to say that.
No, I don't know miles. I don't work with miles.
Fair enough. Well, I work in miles, so.
Yeah. And I try to interpret.
So one of us is going to have to convert this to miles.
Yeah. Okay, I'll do that part.
I appreciate that.
1.609 is the rate.
So you think the sun is 93 million miles away and 400 times bigger than the moon, which is 400 times further away than the moon to make it look the exact same size?
I'm saying that the moon is a sixth of
I'm talking about the sun and the moon.
Yeah,
I asked you.
I've never done the sun moon
I
conversion.
said something crazy. I said I want to refresh your memory there. I said something crazy like, "Would you believe the Earth is bigger than the moon?" And you said no. And then I said, "Would you believe the Earth is bigger than the sun and the moon?" And you said no. And
Okay,
then you
then
said
I
some
misunderstood. Ob-
point where you said
uh,
things so far away, right? It looks like that. So then I asked
yeah,
you
but
how far away these things were, and like the moon is like a mere 238,856 miles away, while the sun is 93 million miles away. But they look the same size, don't they?
yeah,
Why is
yeah,
that? How's that? That's pretty lucky. That's pretty convenient, right?
yeah, because the moon is closer to us,
Oh yeah, totally.
and it
Like
happens to be
like by
yeah,
like by 92.5 million miles, right? Or 92 and 3/4 million miles, actually.
Hey, Soul,
Earth,
yeah.
yeah.
just want to quickly say, do you know what the globe Earth explanation for moon phases are?
The globe.
Yeah.
Say again.
Oh, so
I've
my
never.
question was, do you know like the explanation from the globe model as to why moon phases happen? Like what causes that?
Yeah, because moon travels around the sun, around the Earth,
Mm-hmm.
and the moon is lit up by the sun, and every now and then a part of the moon is shaded by the Earth. So
Now
that's
that's what
what.
you think, right? That's what you
Yeah,
think. But actually, as
yeah,
it turns out, you got people out there that are abandoning that statement now. They're saying that actually it's not the Earth's curvature that's being projected on the surface of the moon, which is always the same. It's always the same face that we can see. Now they say that it's just the position of the Earth relative to the sun. But the sun is 400 times bigger. If there's no barrier between the moon and the sun, then what causes that shade? What causes that darkness?
but there is a barrier, the Earth.
No, well, that's what they said before, right? But even
Yeah,
assuming that that's the case, right? So, like for example, if it's 12 p.m. at night and you see a blue moon, right? Well, not a blue moon. I'm sorry, a full moon. You look
yeah,
up 90 degrees, above you, right? Vertically, you see the moon and it's full.
yeah.
So that's the surface that's technically behind the Earth, right? Although it's not exactly behind it because it's like what 394,000 miles away. That's what they say. You know about that?
Oh,
So
miles. I don't know miles, but yeah, far away.
yeah, okay. So if the surface of the moon, right, that's facing the Earth is being obscured by the shadow of the Earth, how
Yeah,
is it that if it's behind it, how can it be lit by the sun?
but then it's not. And when it's next to the Earth, we see like 47% of it or something.
No, well, yeah, but when the moon is actually behind the Earth, right? Because remember, the Earth revolves around its own axis, right?
Yeah,
360 degrees. And so during the night, right,
yeah,
wherever surface you're standing on, it's facing the opposite direction of the sun.
yeah,
At 12 p.m., when the moon is like, for the lack of a better word, you could just say the center of the sky, right? Vertically, 90 degrees up. You
yeah.
can see it. You can see the entire surface of the moon. It's lit up. That's the full moon. But see, the thing is that they say that the moon's surface is being illuminated by the sun's light. But
Yeah.
if it's behind the Earth, right, and you say that it's due to curvature, so how is it that the Earth's, no, I'm sorry, the sun's light can illuminate the part that's behind the Earth?
Where on Earth would you be? Where is the sun relative
Anywhere,
to?
anywhere, at any position, doesn't matter where.
I would argue that it does matter. Uh,
No, no, no. So like I'm talking nighttime. So like for example, are you in Russia?
I'm in Sweden.
Oh, okay. So let's say that entire hemisphere, let's say it's facing the opposite direction of the sun, right? So you
Yeah,
see a full moon, right?
yeah.
It's 12 p.m. at night. You go outside, you see a full moon. How do you explain that?
Because the moon is slightly to the side of the Earth, and sun illuminates it.
It illuminates all of it?
No, but how does light work? How does
Well, think
photons
about
work?
it.
Okay,
How, like, what would be the angle? Think about it.
no, but if it's exactly opposite,
Mm-hmm.
then it's not visible. You have to have night skies without a moon, without a visible moon, like once a month.
Yeah. No, of course. Of course.
Yeah, like we do.
Mm-hmm.
And
Yeah. So my point is that, like, for example, now they say, well, maybe because I was debating with this one guy, and he said maybe the moon is slightly above the equator. And see, here's the thing: if the moon is slightly above the equator, you got two problems. Number one, there's no reason why, like, the bottom part of the moon, right? You could say like the southern hemisphere, if you believe it's a sphere. There's no reason why it shouldn't be like why it shouldn't have Earth's cast, like Earth's shadow cast on it, right? And also, how do you explain the eclipse?
yeah, but
Because you're facing the opposite direction of the sun,
yeah,
right?
but you're creating a problem here.
No, I'm just telling you what that other guy said. I know you're not making that. You're not making that argument. I'm just,
Yeah.
I'm tossing that
Okay.
out there. The problem is because you're facing the opposite direction of the sun, there should be absolutely no way for the surface of the moon that we can all see to be illuminated by the sun if it's relatively behind the Earth
Yeah.
that you're standing on, facing that surface of the moon.
We also don't see the moon when it's between the sun and us, except if it crosses directly in between, so that we get a lunar eclipse or whatever it's called.
That'd be a solar eclipse.
That's solar eclipse. What's a lunar
Yeah.
eclipse? Maybe that. Okay, never mind.
It's a
That's
dumber
the one we
story.
had
It's a
last
dumber
week.
story.
Okay,
No,
yeah.
lunar eclipses happen during a full moon. Solar eclipses happen during a new moon, right?
No, so solar eclipse is when the moon covers the sun, right?
That's during a new moon, right?
Yeah.
It's the positional opposite of a full moon.
Mm-hmm.
No, solar eclipse is when the moon.
Okay, so you are geographically impaired there, a little geometrically, I should say, geometrically impaired. The one is the opposite of the other in terms of the angle. That if we're looking at a full moon, according to the Globee model, the moon is on the far side of the Earth from the sun. That's why it happens at midnight. That's when culmination occurs for you.
No,
Over
but
your
you can
head.
see the moon at noon. If
Yeah, but if it you don't see the moon at noon.
Yeah,
Over
not
your
noon,
head,
midnight.
culmination.
Midnight.
That's when a new moon occurs, right? Because it's in the same angle in the sky as the sun. So allegedly, you're not allowed to be able to see it because the sun is just too bright. Yet at the same time, people can't slap a solar filter on that takes out the spectrographics of the sun coming at you, so that what is remained is the light coming from the moon. Nobody's ever shown us a picture of the moon during a new moon in the sky next to the sun. It's simply not there. It's not in the visible light spectrum anymore.
no, but
It's
it
not a
can.
physical body.
If the moon is between the Earth and the sun, then the illuminated part of the moon is on the far side of the moon. From our perspective,
Okay. So you're making this big assumption that it is the sun that lights the moon,
yes.
right?
Mm-hmm. Mm-hmm.
Okay, so let me draw this across you. I got 2 points to deal with here. One, are you up to date, or have you ever looked at any spectrographic data and compared the sun's spectrographic signature with the moon's?
Spectrographic signature. No,
Yeah,
probably not.
like
No.
the different wavelengths and the spreads of the wavelengths that come off each of those two bodies. So it's clear to me that you are totally unaware that they're not the same. that there is a different spectrographic spread of light coming off the moon than what is emitted by the sun.
Yeah, but I would
You're
assume
you're
that.
not aware of that.
No, but I would assume
Pardon?
that sun
Why
sends.
would you assume that?
Yeah, because if sun sends sun's rays to the moon, they bounce off the moon, and depending on what material is on the moon, then it'll change.
Okay. Let's do a quick thought experiment here. Let's say you've got a white wall in front of you.
Yeah.
Okay. You're 10 feet from the wall and you're looking at the wall. There's no other light in the room except for a light behind you that happens to be covered in a red plastic filter shield. So only red light is coming out of this light,
Yes.
hitting the wall, and then coming back to you. And now you see the wall lit up by this red light. What color is the wall?
Red.
Right. Okay, now let's put that back on the moon. We've got the light with a spectrographic signature coming from the sun. Certain wavelength bands, more than others, very specific bands, are hitting the moon and then coming back to us. And it's not the same as the ones hitting, coming out of the sun. That's what I'm trying to tell you.
Yeah, I agree.
It is totally different from the replicable model.
It's
So
what bounces off the moon that we see.
So the only conclusion that you can draw there is that the light coming from the moon is not the light coming from the sun, because it is a different spectrographic signature.
Yes, it's the same light, but
No,
depending
it's not the
depending
same
on
light. You
the
see,
same
the moon is supposed to be this big dusty gray ball, right? This big dusty gray rock. You saw all your astronaut friends on there dancing
Yeah.
around on it, playing golf, driving their SUV,
Yeah.
right? Their little 4x4 having a good time in there.
I hear
Okay,
you.
so you look down and there's only one color. It's this dusty gray shit, right? So there is no color of the moon that's going to be coming back to you and changing the spectrographic signature that's coming from the sun if a reflection is taking place. And I'm telling you, according to the data, it's not. It's not the same light coming from the moon. And I'll prove it to you. I'll prove it to you. Okay. Here's the second part of what I wanted to ask you. Are you aware that the moonlight coming at us at night, it's midnight, it's a full moon, there's all this white light coming down here, bright enough that you can read by it. Okay. Notice that when the astronauts are standing up there on the moon playing golf and having a good time, and the sun is out for them, they're everything they got there, all the structures of ships are casting shadows on the moon. They themselves standing there, there are shadows of themselves on the moon while we're taking these pictures of these guys on the moon, right? The sun is out, but